Pat as well for giving us this great facility for 3D Camp Limerick. So, just look, it's great to see so many new faces here tonight, so I'll give you a brief reminder of what 3D Camp is all about. It's a funny name, but it's been around since 2008, originally when it was an annual conference in UL. So Gabriella Avram lecturing there in multimedia and interaction design and myself. We were just looking beyond the Web 2.0, spatial computing, whether that was virtual worlds or spatial computing in the real world and interaction design and so on. So that's where it started. It's become a kind of more regular series of events in Limerick, Galway, Dublin and Waterford at this stage. And it's, you know, the core focus is augmented, virtual and mixed reality and holographic computing now with the HoloLens. But it's also about the related technologies like 3D modeling, as I say, spatial computing, interaction design, CAD, all the stuff that feeds into that. So I suppose the important thing I'd like you to go away with is the idea that it's an open and accessible meetup. It's not meant to be a geeky meetup for geeks like myself, or it's not about coding and developing just. It's about all the disciplines that'll be affected by augmented and virtual reality in the years to come, which is an awful lot of things. So that's 3D Camp. I'm delighted tonight to have John Savage, who is the technical director at Action Point Technology. And I'll admit that I didn't know a whole lot about the company until about October, when I saw a really great blog post by the lads called How the HoloLens Saved My Life, John, I think it was. And it's a really great read. It's a fun read. I won't ruin the story because I'm sure John will tell you about it now. But I was delighted to see that a company in Limerick had a HoloLens, because we've been trying to get one at the 3D Camp Dublin for most of the last year, and it's like they're very hard to get your hands on. So I know you can get them now for about 3,000 quid, but there wasn't too many of them around. So the lads very kindly invited me out to have a look, very open, welcoming office, and honestly, I know this term is overused a lot, but I was blown away. It's an incredible device, and we got our hands early as a company ourselves on Oculus Rift, the DK1, the DK2, and yeah, VR kind of blew me away at the time, but really, this thing is just a level beyond in terms of the feeling of science fiction. That we can actually do this kind of thing now is really pretty amazing. So I know you're going to have a great time when you put that on you later on tonight. And a bit about John and Action Point. Sorry, now I'll have to read out these notes. So as I said, John is co-founder and technical director at Action Point. And it really is a great company. I think we should be very proud of companies like Action Point in Limerick. Fast 50, Deloitte Fast 50, number 9 last year. So that's a really great achievement to have the 9th fastest growing tech company in Ireland in Limerick. So well done, lads. Well done to all the team. John himself is only one of 3 people in the history of UL to get a QCA of 4.0. And I did a similar course to John about 10 years before him, and got a QCA of 2.0, so I know exactly what kind of an achievement that is. But in 2001, he did a final year project called OpenVR, a framework for immersive virtual reality, for which he won the National HP Award. So certainly not a Johnny-come-lately. These guys were at it very early and thinking about it for a long time, way ahead of the posse. So during this presentation, John is going to provide an introduction to the HoloLens, how it works, and how Action Point will be using it in custom software development. He's going to share an honest view of his experience with the headset, including its limitations, unique capabilities, and so on. So please give a warm welcome to John Savage.
Thank you very much, James. Much appreciated. So this is an evening presentation. We've all taken time out of our personal lives. I don't intend this to be death by PowerPoint. I want it to be as interactive and involved as possible. If anything is unclear, if you have any questions, considerations, I'll tell you it's going to come up in the following slide. But feel free to ask it. Certainly, look, let's try and have a bit of fun tonight and get through the information. I'll try and keep it as non-techie nerdy as possible, but ultimately it will be a little bit along the way, so bear with me. So what I'd ask you to do is, you've seen quite a few people trying the HoloLens there while we were eating pizzas, and anyone who hasn't had pizza, there's plenty at the back. Thanks, Pat. Much appreciated. Very much appreciated. If you want to have a go at the HoloLens, we may not have enough time, so what we're asking to do is tweet at Action Point Tech, I want to have a go at the HoloLens. And Kate here on the marketing team will be monitoring Twitter, putting you on a list, sorting you randomly and calling you up then once I'm done to have a go on the system. If you're not on Twitter, then koflynn@actionpoint.ie is an email address, but you do go to the bottom of the list, I'm sorry. So what I'm going to do is hit the right button. So this here is magic. It's basically nothing short of magic. When you try it on and get a go at it, you're going to see why. And I'm saying that in the context of a guy called Arthur C. Clarke, famous science fiction writer. He had the phrase that any technology that is sufficiently advanced is indistinguishable from magic. And this thing, when you try it on, it brings so many technologies together that really it's hard to understand and believe how it works. And don't believe me, this is my 3-year-old kid. So he tried it on about 3 months ago, and that was his first response as he walked toward the astronaut in the corner of the room that didn't really exist. Not scripted, but it just goes to show that's a natural reaction. So what I'm going to do today is a little bit of background on Action Point. James covered quite a bit of it, so I'll be very quick. I'll explain the magic and hope I don't get thrown out of the magic circle because of that. Talk about kind of a practical hands-on experience, what we've done with HoloLens and what the pros and cons are of it, and really how it works. Because I think that's one of the biggest questions people have is, how does this thing work and what does it do? And also a demo. Now, there's a mode on the HoloLens whereby I can, on the laptop, log into the HoloLens. There's a web application, but basically I can put a live preview up here of what's on the headset. And the one piece of advice I've been given by a guy called Ryan Meshes, who's the head evangelist in Microsoft for HoloLens, is that people looking at it on a big screen can get seasick. And there have been cases of people vomiting looking at it on the big screen, so please, exits are that way, don't look too long. But we will try and put up here what people are seeing during that process, just so everyone gets a feel for it, even if you don't get a hands-on of it. Also, while I'm talking, I'm happy to hand this around, just please don't run away with it. As I said, it's quite an expensive piece of kit. To get your hands on one of these, you have to be a Microsoft certified partner. They're only a development kit, so they're not for a public release yet. They're about $3,300. We had to order it to our US office to get it, because they weren't available in Ireland. They are now, to Irish developers. When looking at it, Finian, will you make sure I'm logged out? Finian, just make sure it's logged out. So when you're looking at it, feel free to put it on you. There's, I'll drop this for a second and shout loud. To put it on you, there's a headband here. There's a twisty thing at the very back that adjusts the width of it. The idea is that the weight is held by the headband. This thing should not be resting on your head at all. So you put on the headband first, pull it out, put on the headband first, tighten it up, and when you look on it, you're going to see a very interesting keyboard looking for a password, and I'm not going to give you the password. But certainly have a look at it, feel it on, get a feel for the weight of it. It's, as you can see, it's a self-contained computer. Just get a feel for it if nothing else, and we'll try and get as many people to try it later on. Just make sure it's logged out, reboot, whatever. Thanks, Vinny. Okay, so without further ado, I won't go that way, I'll go this way. I'll hit the right button eventually. So a bit of background on Action Point. We do IT managed services and custom software development. We've got 80 employees, revenue of about 10 million, national, international, so we have offices in London, Los Angeles, as well as Dublin, Cork, Galway, and Limerick. We've won a couple of awards, and we do a lot of work in the IoT space. I won't say any more other than all that stuff. The background, as James mentioned, so you may not know, but this guy here is Roger Downer. So he was the president of university at the point in time. So Roger Downer came all the way down to the CSIS building to try my little old virtual reality final year project. So that was pretty big. And on top of that, we won a national award, National HP Award. It took me an entire year and a half to build the virtual reality engine that was put onto that engine. In 6 hours, where I spent 4 of those hours wrestling with Visual Studio, I did about the same thing with modern tools. So it's amazing the difference that the tool set has made over the last 12, God, it's more than that, is it? God, it's 15 years. Anyway, but just to give you background, even on this, so these guys here, so that's me a long time ago. I've hopefully not changed too much. So Roger Downer is sitting in a hovercraft. If he looks behind him, he'll see a little spinning blade and stuff. He's got steering wheel and pedals, so he's actually driving a hovercraft, and as he moves the wheel on the hovercraft changes. Myself and the colleague from IDC, I don't remember her name unfortunately, we're 2 other players. So my monster PC, which is probably less powerful than my phone now, was running a 3-player game where myself and her were playing on the keyboard, and he was racing with the thing. We beat him. That's an idea of the virtual reality that we did back in 2001. So this is an idea of what we've done with HoloLens so far. So really we're just kind of exploring it. We really are playing with it at this point in time. We have a very strong idea of what we're going to do in the IoT space with the HoloLens. We're looking to take the data that IoT systems build and stick into the cloud, but actually bring it back into the real world. So that wearing the HoloLens, you can walk around the factory floor and see on the relevant machine the information for that machine, rather than only seeing it off up in the desk. So it's kind of like if you walk around the factory floor these days, you'll see a stack, as they call it, which is a set of traffic lights. And that stack is basically red, amber, green. It's working, it was broke recently, or it's completely broken. And what we want to do is, using the HoloLens, put augmented smart stacks on top, whereby you still look around, they're all virtual, you tap and you get way more information. That's kind of where we're going with HoloLens. The story James referenced, Greg Bernas is here. Greg was our developer that stayed working with me. I was in Austin, Texas. We had a demo kit going to Dell World that didn't arrive. Delta lost it in transit for a 4-day trade show and arrived the night of the 3rd day, so we only had one more day left to go. I had to build out this 2 meter by 1 meter smart factory thing. I'd never done it before. Greg had done it many times, so I wore the HoloLens for 9 hours straight. Took it off for half an hour to charge it, so I know there's a 4.5 hour battery life. I wore it for the 9 hours. I knew I was wearing something on my head, but it didn't kill me. It was actually comfortable. It was comfortable. Greg in Ireland and me in Skype. So this is Skype on HoloLens. So Greg could see my point of view. So a couple of times, more than times than I'd probably like to admit, I was going to plug something in the wrong way and fry a few circuit boards. But because Greg was able to literally see what I was doing 24/7, he was able to say, no, swap them around, reverse polarity or whatever it was. Likewise, I'd say, I just drop an arrow somewhere, what's this about? And I'd literally draw an arrow with my finger. He'd see that arrow on the factory, and as I moved around, the arrow would stay at the same place. So at the end of the whole thing, we just took this shot here where, to explain it, this is the factory we built. This is me, I just scribbled the word done with my horrible handwriting that doesn't work. That's Greg's view, so I could place his view wherever I wanted. So when I was working on something, I could have it in front of me, I could have it over here, I could bring it with me. So the view of what I could see of Greg, I could move wherever I wanted. And this one is a real head messer-upper. I won't use the blunt term for it. This guy here is Greg shared his desktop. So it showed up as another window. So that's Greg's desktop. But Greg's desktop was him remoting into the Dell gateway that was behind me in Austin, Texas. So I, via augmented reality, was seeing a computer behind me shared from Greg and hovering in space. So it's just, but it worked. And we had to do a lot of configuration work, and that was the two of us working in the same configuration. I can tell you one thing, we would not have built it without HoloLens in the time we had. And we got it in there for the last day of the trade show. And Greg got out at 7:15 before the other staff started coming in, because we didn't want to have that awkward conversation. You started early? No, I haven't gone home yet. So that's an idea of what HoloLens can do for you. It's a very kind of interactive, constructive tool when used in the right way, correct? Okay, so reality. We're all talking about augmented reality, virtual reality, blah, blah, blah. Let's talk about what we mean by the terms. And James, feel free to disagree and correct me when I get it horribly wrong. So virtual reality, when someone says virtual reality, what they really mean. Do I need a microphone? Are we okay without the microphone? Okay, yeah? Okay, so virtual reality is when you're in a self-contained universe. You can't see the physical world around you at all. So it's great for sitting down or very, very, very constrained spaces. It's largely an entertainment thing with some training work, but it's self-contained, so it can be dangerous for moving around. Newer systems are getting better at telling you when you're going to walk into a wall, but you still can walk into a wall wearing virtual reality. Augmented reality, the simplest augmented reality that I hope you're not familiar with is Pokemon Go. So augmented reality is when you just overlay something on the physical world and it looks like it's there, but it's not really interacting with the real world. That's what augmented reality is. Generally, smartphones held up with an overlay is kind of augmented reality, and there are some headsets that do basic augmented reality. Mixed reality is the genius that the HoloLens delivers. What mixed reality is where you mix the physical with the virtual. So what the HoloLens is actually doing, and I'll go into detail on this, is it's not only rendering a virtual hologram into the real world, but it has also physically scanned the three-dimensional space of the real world. So what that means is if I created a holographic ball here and I dropped it, it would drop, it would land on the table. If that table was at an angle, it would actually roll off the table toward the angle, go on the ground, bounce off this thing over here. Like the virtual item is interacting with the physical world in a very convincing way. That's what mixed reality is, and it is stunning when it works, and it does work with the HoloLens.
What would be, like some virtual heritage applications, for example, would make use of a smartphone and take advantage of the mixed reality like that. Like the example is you go and you look up the building, you change the buildings into back in time.
Yeah.
What would be the massive advantage of having a HoloLens over one of the applications you can have for your headset with a smartphone?
The immediate one is hands-free. The immediate one is hands-free. So especially, like, I think HoloLens is going to crack the industrial space because the hands-free ability to get assistance. So I was able to use two hands, putting that factory together without holding a smartphone up at an angle and using one hand or anything. It was just there. Everything that I overlaid was just there. I didn't have to have anything else. So like even if you, let's say you get a guy with a tablet with information to fix a machine, when he goes to the machine, he's got the tablet, he's like, I'll put it down here and I'll fix the machine and I'll take it up. Whereas with the HoloLens type approach, you can have a screen up here and you're just glancing at it and it's floating wherever you want it to be. So it gives you that sort of real ability to use the best of the physical world while also bringing in the best of the virtual world. It's that sort of combination. Does that answer your question?
Could I say, for example, if I was working with maps or something, would I be able to look at like a physical copy of a map and do something with it virtually?
Yeah, certainly. Yeah, absolutely. Yeah, that sort of interaction stuff, like QR codes, you get that sort of pop-up thing coming out of a QR code type thing, yeah, that you can do that. So, cool. Keep questions coming. Merged reality, I only read about this last week. It was in CES. So merged reality is when virtual reality takes in the physical world. So the idea of merged reality is that you still have the virtual reality where you don't see the real world, but let's say I put on a headset in this space here and the virtual reality is in a spaceship. Well, it becomes merged reality if the headset is aware that there's a chair there and it converts it into the con so that I know that I can't actually physically walk through it, but it's a virtual device. So it's taking the physical world and representing it in the virtual world. That's what merged reality is. Okay, so they're kind of the four big things. Ultimately, one of the things they all have in common, or three of the things, is head tracking, stereoscopic 3D in real time. They have to operate in real time. Minimum is 60 hertz or you get violently seasick. Stereoscopic 3D gives you the depth perception of that. You don't feel that it's actually in the world. And head tracking, you move your head and it does nothing, it will fail. Okay, so keep going. So, greater than the sum of the parts. So a lot of us nerds focus on the individual tech specs. What's the refresh rate? And how much RAM is on it and blah, 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 blah. I can't emphasize enough that this definitely delivers on something that's greater than the sum of the parts. And where I'll give you an example is I do a little bit of drone racing in the very little spare time that I have. So if you ever look up drone racing, this is the sort of really, really cool video that you see. And you're like, oh my God, that's amazing. The pilot must be using that. It's all a lie. This is a HD camera that sits on top of the drone. You can see lovely green, you can see the individual blades of grass, you can sense the speed as you're ripping out, you can even see the wind fluttering on the thing. Lovely, this is up in the burn, so a nice area. So that's an example of what you see online as being brilliant. From a tech spec perspective, that's 1080p, it's 60 frames a second, it's just perfect. However, when you're actually flying, this is the horrible murky crap that you fly with. So this is a live stream that comes onto the goggles that you fly with. So you'll notice that, sorry, you're going to get a bit sick, but when I make a left turn here, the video gets all crackly. That's very common. When I pitch up and I see more sky than ground, the whole color contrast changes. It is absolutely horrendous. You see ghosting, and the whole lot just becomes a soup. So I'm going to stop it here because you will get violently sick. That doesn't look like the ground. But when you're in there, when you got the goggles on, these are the tech specs for what I'm flying with. I'm flying with 400 horizontal lines. Horrible. Poor color, stability, ghosting. You'll see double images every so often and you get dropouts. The whole thing will freeze and come back again. And I've got a 60-degree field of view, so I don't have a very big field of view. So it's pretty poor from a tech spec perspective. However, the two key elements are the render loop, as I will call it. It's instantaneous. It's 50 milliseconds, give or take. So I move the stick, 50 milliseconds later, I see what happens. So you are there. It is 100% responsive. If you're using HD video, it's going to be about a 500 millisecond response time by the time it's encoded, decoded, blah, blah, blah. You couldn't fly it. Likewise, tongue-in-cheek, it's a perfect landscape renderer. Yeah, it's real life. So the lighting is correct, the shading is correct, the occlusion is correct, everything is correct. It's rendered pretty poor from a pixel perspective, but because what's being rendered is perfect, it's just so convincing that you shake from the speed rush and you physically fall off the chair when you crash. So it's much, much, much greater than the sum of the parts. And that's what HoloLens does. There's a few drawbacks, but the sum of the parts is way more than any of those drawbacks might believe hold it back. That's 3 times in a row, I got the right button. Excellent. So what is HoloLens in a nutshell? It is an untethered standalone computer, so that's pretty unique. An awful lot of VR and AR experiences have you tethered via cable to a computer for power, compute, and video. This thing is standalone. So I don't know if you've felt the weight of it yet. It weighs, I don't know what, a pound, pound and a half. It's not that heavy. It's got 4.5-hour battery life, which I actually experienced. What it actually is a reverse Kinect. If anyone's familiar with the Kinect that was on the Xbox 360, so the Kinect would sit on top of your TV, which I can't reach, but it would sit up on top of your TV. And And what the Kinect did was it scanned your room. It did a depth scan of your room. And the assumption that the Kinect made is that it was stationary. So if it saw motion, it assumed it was you. It's as simple as that. What the HoloLens does is it sits on your head and it makes the reverse assumption. It assumes that if it sees motion, you have moved towards it. That is fundamentally what the Kinect is doing. And it is constantly scanning the depth of the room. And as you're moving around the room, it sees that all of that moved towards me, so I've moved forward 500 centimeters or 50 centimeters or whatever.
Is it essentially working from structure from motion?
It's visual-based depth sensing. So there's two stereoscopic. I'll show you the technology in a second. I don't know the computation. It's pretty funky computational methods is all I can say. There's some video of it doing the whole depth sensing stuff, but it is phenomenal. Also, because there's no mouse or keyboard, it's voice and gesture control. So I'll talk through the voice and gesture, but basically you talk to it and you wave your hand around, and it's total sci-fi stuff, and it works really, really well. And it connects to Bluetooth peripherals. So if you want, get a Bluetooth mouse, Bluetooth keyboard, sit down with no monitors in front of you, but have 3 monitors virtually that you play with your keyboard and mouse. So it is a full-blown PC. It's a full-blown Windows 10 computer. So here is some of the technology. So depth sensing. So these two cameras here and these two cameras here are your depth sensing cameras looking out into the world. You've got 4 microphones, so it's very heavy in the audio. And these guys here are what they call the mixed reality capture kit. So the mixed reality capture kit is when you see videos online, it's actually captured from here. So it's not your left eye or your right eye, it's actually kind of a camera dead set in the middle. When we turn on the video capture on the computer or do record, your resolution drops on HoloLens. It's just the side effects of the copy. Sorry, of the rendering remotely. So these guys here is the heart of the system. It's not like LCDs or OLEDs or LEDs or anything. It's something really funky and new called a holographic waveguide. These guys here, the one complaint you're going to get, and I'll talk about it in a bit, is the field of view on the HoloLens is relatively narrow. Microsoft are very explicit because we all say, sure, that will get better in time. It won't. They're very explicit that there is physics-based limitations in how wide this field of view can be, rendered by these guys here. And the line I heard is that for the 30-degree field of view, these guys here still cost about $800 per lens, per HoloLens. They're about $800 on these guys here. To get like a 60-degree field of view, it's about $9,000 to get waveguides that do that sort of field of view. So there are physical limitations. This thing is pushing the edge. It doesn't render images, it adds light to your eyes, is how Microsoft describes it. So I don't know, make up your own mind on that one. Maybe I swallowed too much marketing Kool-Aid. This guy here is what they refer to as the HPU, the holographic processing unit. So it's a custom chip. It handles all of the data flowing from all of the sensors. The number I've heard is it's north of a terabit a second of data flowing through the HPU to try and a terabit. Terabit, that's a lot. It's got a lot of zeros. Yeah, it's huge. It's absolutely huge. You got the 2 depth sensing cameras, each rendering a pretty high resolution, flowing through 60 plus frames a second. It's phenomenal. It's absolutely phenomenal.
What would you need in terms of input to put into that? Would you need like something insanely high-tech to put into it in the first place?
Everything you need is on it. You just walk around the room. It's phenomenal. And then the audio. So these guys here, they're spatial audio sound. The sound just appears over your ears. You're not wearing headphones. The test of these was I put a hologram that made noise up into the corner of my hotel room the day we got it. And I was on the trip with Ivan, our head of IoT. And I got Ivan to close his eyes, put on the headset, and try and locate the hologram using sound alone. It was here, and he got to it in here from the other side of the room. So using the audio alone, you can hear it very clearly, up, down, left, right. It is the spatial accuracy of the audio that this thing generates is actually second to none. But what will the HoloLens do for us? Please tell me you've seen The Life of Brian, or this will be lost on a lot of people. So, this is all tech spec stuff, but what does the HoloLens actually do? So the key thing it does is it works out where you are in the world. And it does that in a kind of layered approach, like any good software system. It just builds layer upon layer upon layer upon layer. So the first thing the HoloLens manages is spaces. So by coming in here today and connecting to BOI Guest Wi-Fi, we've created a new space in the HoloLens. So next time I come up here, power up, and the HoloLens spots BOI Guest, it knows, that's the BOI Guest space. That's fundamentally, it uses Wi-Fi to understand roughly where in the world it could possibly be. Once it knows it's in the space, it then starts doing depth checking. So it is absolutely nuts. So the next time we power up the HoloLens, it'll know it's in BOI guest. I'll look around and it'll go, oh, that pillar looks familiar, and it'll check the entire 3D space that is captured in this room. It'll go, oh, that pillar is a fairly unique thing. It matches this thing, so John must be, 500 centimeters from the wall over there and 2 meters from the wall over there. That's what the HoloLens is physically doing. It is physically scanning the room, trying to match where you are then within the room it's aware of for the space, and then locating you at that point. It's amazing.
John, just when you say scanning, it is just visual, it's processing visual imagery, doesn't it? It doesn't have some sort of a...
My next slide. It's got an awesome video.
No.
As I said, I'll answer everything on my next slide. No, but the next slide shows the tessellation. It is very hard to describe, so a video speaks a million words.
I make 3D models, including models of 3D space as well, or I'm learning rather, and it just takes ages. So try to comprehend how that's doing it.
Yeah. So visually locates you in a space, and then spatial anchors are critical. So spatial anchors are, it's very, very technical, so I won't spend long on it, but ultimately, when I place a hologram on the table here, what the HoloLens does is it not only places the hologram there, but it puts what's called a spatial anchor there. And let's say I kick the table and I move it literally a half a centimeter, the hologram will move with it. But that means that the hologram here has moved relative to the hologram here. So it creates a spatial anchor that's tied to the physical geometry closest to where you've placed a hologram. And that allows also, as it refines its understanding, like the first time you glance at that, it'll be a rough square and it'll refine. But as it's refining, your hologram isn't popping and moving. So these spatial anchors is what gives that absolutely locked feeling when you're looking at holograms. They do not move when you shake your head and look around, based on that spatial anchor technology. So this is a video of the tessellation, of the depth perception. So I'm looking around the room. Anything that's not covered, it doesn't know yet, but you can see it's very quickly going, oh. So it's identifying there's a wall there, oh, there's a TV there, oh, it's a bit out a bit. It starts tessellating the table here. Then you go into the gap here, and you notice when I go into the gap, it thinks it's one physical connection first. See there, it says that's a physical connection. It goes, oh wait, there's a gap there, and you can see it very quickly, realizing, oh wait, there's actually physically a gap there. So it's constantly looking and refining its understanding of the world. You'll see it start spotting the leaves, it starts seeing the wall, and then it now understands the whole room. And it's actually built a 3D model of the room by you standing there and looking around like a complete dork for about 10 minutes. Well, not 10 minutes, 2 minutes. It takes 2 minutes to scan a room of a medium size. And yeah, everyone does look at you a bit odd. But that gives you an idea. Does that kind of give you, so by the end of that, you can see very clearly there's a triangle-based 3D model of the room that now is available for you to do it. Once you have a 3D model of the room, you can now do everything. You can bounce stuff off walls, you can occlude, which is really cool. The 3D model generation is the secret sauce. That's the magic. Pros and cons of the visual location services. So the pro is no GPS or beacons required. It is 100% standalone. It's entirely visual. You basically turn the lights on and you can work out what the room is. It gets a 3D model of the world. So by virtue of you having a 3D model, I'll use this as an example, I'll use you as an example as well. When I stand behind that, he disappears because that's the physical way physics work. It's not complex. But if he's a hologram, he's there virtually. So when I stand behind that, the computer will just render a hologram that looks like it's far away, but I can actually see it. So it gets very confusing very fast. But because it's got a 3D model of the room, it knows to occlude, and I'll just see the corner of him. So it's phenomenal. I've got a video of that. And occlusion is the real, like, oh my God, that's what makes holograms live in your environment. Occlusion is a key thing. And then collision detection, if you walk into something, if you throw a ball at something you wanted to stop, then you need the 3D model of the room to do that. Cons, and this is a big con, is large, open, dynamic, or repeating spaces. So we've got a large space here, very open. There's lots of people moving around. This is hell for the HoloLens. This is absolute hell for a HoloLens. Also, a factory environment. Yeah, Finian is like, oh, is it totally broken? So a factory environment where you got 25 lines that all look the exact same is going to be difficult for a HoloLens to work out exactly where it needs to be.
How about like glass and light? Would glass and light throw it at all?
Something, yeah, I haven't yet figured out exactly if it sees through the glass or not. So it kind of does, but then doesn't, then does, then doesn't.
What I found from trying to build 3D models in motion is that when you get glares and stuff,
it sees a glare as solid, but it sees, yeah. So yeah, and you end up with things kind of half stuck in the glass then is a problem. So yeah, there is a problem there as well. But it's a con. Again, going back to the sum greater than the parts, you live with it, and if you're aware of it, you won't allow it to cause you issues. Audio, from audio perspective, it's got Cortana voice control, so you say, hey Cortana, start recording a video. Hey Cortana, take a photograph. Hey Cortana, launch email. Hey Cortana, shut down. Hey Cortana, tell me a joke, and she'll tell you a really stupid joke. But Hey Cortana is the trigger. It's kind of like Alexa is the trigger for the Amazon Dot. In-app voice control is very, very easy. If you're doing development, you literally give it a lump of strings. You just say, I know this command in text, and it'll just understand the thickest to carry accents and allow you to control it via voice. So it is very easy to code the whole voice input side of things. So it's really designed, again, for hands-free. You don't want to be messing with it. You just talk to it, which is brilliant. And the spatial sound, highly locatable and easy to configure. Again, you literally create in your world an audio source that's got a tick box called spatialized ticked. And as soon as you have a spatialized audio source, it will 3D locate that in the room, and you will be able to find it with your eyes closed. It is that solid, that good. And gestures. And this was 2001, 2-ish kind of type thing, Minority Report. And a really cool thing is we're actually more advanced than this guy because we don't need gloves. It's all based upon just the depth sensing camera. So you've got hand controls without actually any tracing, white beacons or anything on your fingers.
Can you do the thing of drawing up the screens like you can?
Yep. You move around, everything, yeah, absolutely. So the gestures to be aware of when you're using the HoloLens, to talk through them for a second. Gaze is very simply where your nose is looking at. So we often have the thing where you're looking over here with your nose, your eyes are over here, and your hand's over here. That's all that matters. That's gaze. And what it does is it basically puts a dot in the world. When you're wearing it, you'll see a tiny little dot. That's where your nose is. So it doesn't matter where your hand is, so long as your hand is visible, it's where your nose is pointed. Tap is, I call it the loser. So loser, you're all losers. So big L sign, you just tap the two fingers together. Technically, it's just a drop of the finger, but it's easier to conceptualize tapping your finger off your thumb. So literally, that is tap. So when you pull up the virtual keyboard, you can just go JOHNSAVAGE, and it will operate at that speed. It is extremely responsive. I haven't had an issue yet of it falling behind or not spotting a tap. As long as you hold your finger like that and not like that, give it a chance to see your bloody finger. Hold and drag, so you just tap and move around. So I got one of our apps that we built about 6 months ago, before we even had a HoloLens, running on it actually yesterday. So I walked the whole way through the office like this, bringing it down to show the guys in support, hey look, it's working, and I had to walk the app back again. So yeah, you just lose your dignity with this thing. But that sort of hold and drag is really, really cool. You just literally, it's a very intuitive way of operating. And then Bloom, Windows key. So if you do try it on, one of the people here that tried it on had a problem. They were saying, there's loads of squares and icons and stuff. Couldn't figure out what it was, put it on straight away. Bloom is your Windows key. So you hold your 5 fingers like this and you just go like this. A lot of people get very theatrical and go like this. It's just literally that. So put your hand up, and that's the same as Windows key. So do that, your Windows menu comes up. Do it again, your Windows menu goes away. It's the same as Windows key in your laptop. So when you do that, your Windows menu comes up and you can say launch an app or do whatever it is. All your apps are on your Windows menu. Very intuitive, and it's all enabled by the depth camera, so there's no need to have anything physically on your hands other than having hands. The world is your desktop. So this is an example of the way HoloLens works is when you go into a new space, there is nothing there. So you generally open up the start menu, you pick your applications, and you drop your icons somewhere physically in the world. So you might have your games over here, you might have your settings over here, you might have your work apps over here. The advantage is it's really, really neat because you quickly, settings, and you get to them very fast. You get to them a lot faster than you would with your Windows key and start, run, and blah, blah, blah. So the human mind is actually amazingly powerful at processing spatial information. And this allows you to lay out your workload in a spatial way. So fantastic pro. The con is, imagine every time you power up your laptop, you've got to rearrange your desktop. So basically, when you take this HoloLens to a new location, you got to go set up your desktop again. And that's the con. But look, it's a minor one. Again, these are limitations. As a nerd, I got a bitch and moan, but in reality, it's greater than the sum of the parts. So this is an example of rearranging the desktop. Now I'll click this over here to make sure it goes. So this is how you do a rearrangement. So that's the weightlifter, which is over here. So you can see, just click and drag, catch the corner one, I turn it, and then I click and drag it, move it in and out. That's how intuitive it is. Very, very simple. I think it's looping, isn't it? Yeah. So when you're doing holographic movements and motions and stuff, once you put it into a data adjust mode, that's how easy it is to move stuff around with you. Now, if you don't want to do 3D stuff, you can do 2D stuff. So a regular, like an Excel-based application or Internet Explorer or whatever. So this is an example here of Edge, i.e. Edge running a bunch of manuals. So like this is kind of the manuals for a sensor, and this is a 2D IoT application that says your machine is running. And they just sit there like screens that float there, and you can put into a mode where they actually follow you around, which can be useful. So it doesn't all have to be
holographic.
holographic.
Would you pin those screens to Surface as well, even though they're traditional apps?
Yes.
You could.
Now, you can't be a traditional Windows exe apps. They have to be Universal Windows Platform applications, which is they're a pain in the behind to deal with. But that's fundamentally what they are. They're Universal Windows applications. But we built a Universal Windows application going back, actually December 12 months is when we built it, and I just copied it on and it ran. Okay. So that's the upside to the UWP platform, is it works out of the box on loads of different technologies. So mobile, Windows 10, regular desktops, and now holographic. Microsoft are trying, and I hope to God all the developers say no, because it's a horrible platform to deal with. But I'll take that one offline. So this is an example of everything coming together as magic. So this is the start of a game called Conquer. This effect here is called the portal effect. So it's actually created a hole in the wall. So you can see as I walk around, I'm seeing through the hole in the wall, but there's no hole in the wall. It's amazing. And he jumps out with his lack of clothing, and he puts his clothes back on again. But that's the sort of stuff that HoloLens can do. It puts a hole in the wall and allows you to look into another world. And it's so convincing, it isn't funny. Next then on this as well then is tap. Come on, get out. Yeah, so this is me playing the game. So this is a full platform game running in the room. And you see, as I've gone behind here, see it's all occluded. So it's deliberately telling you there's something there, but it's rendering it differently when you're behind a wall. So that's the decision the game makers made, is if it's occluded, I'll just make it black. You could also have it so as if it's occluded, it's gone, which is a more realistic thing. But from a game developer perspective, you want to know that they can still see it and not lose track of where things are. As you see, I'm running up the wall, running down the wall. You know, it's pretty cool. It just took over my room. Something is plugged into the chair over here. You know, it's very, very, very interactive. And that's just from the scan that you saw me doing a couple of minutes ago. It's worked out the 3D model of the room. It's worked out what walls are, what floors are, and then it's put platforms and jump pads and whatever, wherever makes sense. I think that's about all on that one, so I'll skip on. Practical limitations. So to talk about it for a second, the field of view. The field of view is equivalent to, I have a 58-inch TV at home. I sit in the couch about 2.5, 3 meters away from it. I put on the HoloLens, and the field of view of the holograms was actually almost exactly that 58-inch TV 2, 3 meters away. So it's reasonable, but not huge. The other thing I did was I held the iPhone about here, you know, reading distance for the iPhone. That's about the field of view. From a numbers perspective, Microsoft don't publish numbers. The best I could find was someone said it was 30 degrees horizontally, 18 degrees vertically. So it is limited, but it works. When it comes to mixed reality capture, so when you see videos of holographic experience, of HoloLens experiences online, bear two things in mind. One is a very good thing, one is a very bad thing. You will look at it and go, those holograms are jumping all over the place. They only jump all over the place on the mixed reality capture. They don't when you're wearing the HoloLens, and I can't explain why. It's sad. So the video you capture is not even remotely as solid as what you see when you're actually playing with it. And the other thing is, when it's doing mixed reality capture, it shows the holograms all over the place, but you only really see them here. So it kind of tricks you into thinking there's a wider field of view. So it's really cool Microsoft marketing videos where they've got people up close with a bike and doing this over here, and they can't see crap, you know. So that's the side of the mixed reality capture side of things. Another one, this is, it's been me being overly pedantic, but the HoloLens scans the physical world, but it doesn't understand the lighting sources. So what that means is that when you yourself create a hologram and put it into the world, if you light it stupidly, if you light it from the bottom, it's going to look out of place. So you have to be very careful when you're making your holographic content that you put kind of ambient, non-specific lighting on it. Because the lighting of a hologram here technically should be very different with these spots than an office with strip light fluorescence. But the HoloLens just, I don't think it's physically possible to understand there's light coming from that window and da-da-da. So that's the one limitation, is getting your hologram to blend from a lighting perspective into the physical world is something that the artistic guys are really good at, and I'm not. Busy, similar spaces. So again, if you bring this to a trade show and you're in a booth and everyone's walking around the whole time, it will malfunction massively. And that's one of the reasons why you cannot get a demo of HoloLens from Microsoft, because they are so scared that they give you a demo and it's crap. We're all friends here, so if this one doesn't work out, we'll know why. but Microsoft wouldn't risk that. So yeah, fundamentally, the reason why is if the space is moving, if there's lots of people moving, well then you're going to end up with the HoloLens losing track of where it is. And you get a message of tracking lost and all your holograms disappear. That's the best message. The worst one is your holograms literally appear in random places, which has happened as well. And then configuring new spaces. So again, we had to come here about half an hour early to put the holograms everywhere, because when you come into a new space, they're not there. But again, look, I'm lazy. I don't want to do stuff like that, but I have to. So I'll complain. What happened there? There we go. But remember, this is Magic 1.0. Okay? So this is version 1.0. It will improve. It'll only get better. The field of view won't. I've been assured of that. But like, it is really, really, really solid. And yeah, what it does is only going to get more powerful. So this is the only really technical slide for anyone here that's a developer. Are there any developers here at all? Yeah, okay, cool. Right, I will go through it then. So you've got two choices. You can build a 2D application using the Universal Windows platform, and then it'll render it in a floating 2D window. That's option one. It sucks. If you do that, you're not doing holographic stuff. You're just running normal stuff on the HoloLens. The really cool stuff is you build a 3D Unity game. So you use the Unity game engine to build a 3D world. Yep. That's kind of the default preference. You can hack stuff together with C++ if you really want to do it to yourself. But it depends on what Unreal Engine has the HoloLens plugin. So basically, Unity has got a plugin that directly outputs a Visual Studio Radio file. So everything you've done in Unity, configuring your hologram locations, your actions, your scripts, everything, when you click Go, you get a Visual Studio solution. You open up Visual Studio, you do whatever further configuration you want, and then you deploy it to your holographic emulator. So you don't have to wait till you have a HoloLens to do development. You can do it on the HoloLens emulator, which is how I started. Plug in an Xbox 360 controller into your laptop, and now using the sticks, you walk around like you're playing Unreal. You move around and look around, and you get the full sense of what you would with the HoloLens. And the app I developed on the emulator, I literally got the HoloLens, connected via USB, and it was on it within 2 minutes. So the emulator is what you get. But from a pipeline perspective, yeah, it is Unity, is the default way. Anything else, you're kind of on your own, would be the way to look at it.
And is there any way that you can use the hardware on it and put it towards a different application rather than Unity game? Like, because what struck me immediately about it, it's got such good building of 3D and stuff that could save me an awful lot of time if I got one of those compared to going and building up 3D maps or something from taking photos all around and things like that.
Yeah.
Is there any way you can do that? Or?
Possibly, to be explored. Yeah, that's what R&D is for, I guess. I don't see a reason why not. It's down to having the pipeline to go from whatever your preferred tool is into HoloLens. That's what the gap is. Unity is clicky and it's done. Anything else, if you can make it work, you can make it work.
That brings me to another question. So like say if like there's obviously probably an awful lot of programs you couldn't run on it then that would be built for kind of desktops and things like that.
Oh yeah, you can only run holographic, let's be clear, you can only run holographic apps on it. You can't, it isn't that there's lots of programs that don't, it's like there are very few programs that do. So you have to build a holographic app. The structure of your holographic app is literally you create 3D models and you create scripts associated with inputs. Your input could be a gaze. So when I look at it, it gets a little bit bigger or it starts pulsing. As soon as my cursor is on it, it might pulse or it might rotate. When I look at it, look away from it, it stops. That's one example of input. Then what Finian is doing over there. So tap is another one. So you literally have an on-tap gesture event that the HoloLens framework passes up into Unity, and you react to that by calling a web service and saying, hey, what's the status of my machine? And then changing color based upon what the status is of your machine, or maybe rendering a graphic graph on your object. So you've got full interaction. Also voice commands, you literally on your device say, reacting to voice command of hello. And if you look at it and say hello, then it'll do whatever you scripted to do. So it's very, very flexible and powerful. Each hologram is game object. You add the scripts for each of the activities, and then up to you what you want to do with it. But that's fundamentally how you do it. You add on, you basically turn on physics for a device or for an object, and it will fall and naturally roll around the table. You create a square and it'll fall and just sit there. You create a circle, it'll fall and roll off. It's phenomenal what you get out of the box with Unity. And maybe Unreal does the same thing. So stop, demo time. This did work earlier, so we're going to give it a shot. Are we okay? All right, so chill over here. So what I'll do here, good burn. So to explain what's going on here, so this guy here, again, standalone untethered computer. What we have is a web server on the computer. And on the web server, I can do live preview. Well, actually, no, before I do that, 3D view. So 3D view. Hi, ballerina.
So is the web service running on the HoloLens?
Yes.
Okay.
So I'm logged into AP HoloLens default. I didn't download the cert, so it's saying it's not secure, but it is. So I go to 3D view. And when I go to 3D view, you can see as I look around, there's my head looking around. Ooh, very exciting stuff. What's really cool is when I click the update button here. What the update button is doing is pulling in what the HoloLens has as its current understanding of the room. So you'll see, where's the pillar? So I'll walk over to the pillar, you'll see the pillar on the thing. Do you see roughly where the pillar is? I might have to zoom in a bit. So let's just see now. Oh yeah, there's a pillar. Yeah, so you can see the pillar over there. So there's a pillar there. Come on. Oh, I can zoom out, but I can't zoom in, is it? Oh, great. What did I do there? Which way do I have to pinch to zoom in? Come on. I don't even know how to zoom. Oh, there we go. There we go. So honestly, in that mess of pixels there's a really cool rendering of the room. I'll give it one more shot. Double click. No. Yeah, which doesn't exist on a touchpad. Thanks, Paddy. So look, it's hard to see because I'm all the way out, but that there is a fairly detailed. So there's actually a floor plan. So there you go. Look, I'm looking at the wall. There you go. I'm looking at the wall. There's a pillar. There's a bunch of chairs, and it actually has a rendering of the chairs. There's a bench at the very back. So we're after walking around. So Finian's walked around the whole room and basically mapped the whole room. Now, you can actually download that as an object, going to your point. You can download this as an object in a well-formed, sorry, I'll take it off, in a structured 3D object and bring it into an environment. As you can see, it's a little bit messy. It's not, perfect, crisp, clear, but hey, it does the job for occlusion, collision detection, and so on, because that's what it's for. It's a physics object, not a visual object.
Sure, if you needed to make a 3D thing perfect and tidy, you'd have to go around and look at all sides of everything.
Oh yeah, yeah, absolutely. But this is a whole lot cheaper than a laser scanner.
Yeah.
Um,
The one that we have in college cost $6,000 just to calibrate and move it as well.
Yep. That's an example of, yeah, so let me just see now. Mixed reality, 3D view. Boom, 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 gone again. Show still Argentine. Sorry guys, now there is something here that is kind of cool and I can't find it. Must be in here. Oh yeah. System information. Where's my cursor gone? Sorry guys. My cursor is AWOL. There we go. Basically, there was a screen here that would show you your hands. And as you held up a hand, it would say, oh, I see a hand. But I can't find it now. It was really cool, I swear. Show details. Dun, 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 dun. Ah, there we go. Okay, so here's my head rotation. So it's on my hand there for a second. So I'll put my hand up here. Come on. Come on, Mr. HoloLens. There's my hand. There's my location of my hand. And CD is pressed. Bang. There's impressed with my finger down. Not pressed. Pressed. Not pressed. Ooh, this is really cool, isn't it? That is phenomenal. The fact that that works is absolutely phenomenal. So you'll see true false changing here as I just tap my finger and let it go again. It's hilarious. You put so many holograms around here, isn't that funny? But that's the sort of stuff it does. So it's aware you got two hands. So there's one hand and there's my other hand. Yeah, there's my two hands. So that's all out of the box. So you can see from a programming perspective, there's a hand. It's the left hand or the right hand. You know exactly where it is. You know if it's pressed or not. So from there, it's very easy then to build in your gesture management and so on. Then the last thing I will do before I hand over to whoever is up first. Have you got your list, Kate? Have you been? Live preview. So, hang on. So the challenge with live preview is because of the bandwidth it requires, it actually ends up falling behind. So here you are. Here's everybody in the room, and see all the holograms have been all over the place. So spaceship. Okay, so ballerina, and I will tap the ballerina and hit play. Now, I don't know if you can hear the music, but there she is showing you how to do some ballerina type dance.
You know what it is.
I can even do a plie. And then, because I have to recover from that one, here's a weightlifter who's going to show you how to do there's a thing in the middle of it. So I don't know if you can hear that, but he's explaining how to do a squat, clean, and jerk. So, as you see, you can go right in close. I can shake his hand. He's right there. He's physically there. And as I move around, you know, I think you understand what I'm trying to say. It's just there. It is physically there for all intents and purposes. There's a spaceman up here. He's going to wave to us and say hello. Is that still keeping up with us? Yeah. Spaceman, so he's kind of, hi, it's Mr. Spaceman. So I walk right over, hi Mark, how are you? So there's a spaceman, but like he's physically floating right there. And it feels, when you put your hand through it, oh, so that's the Windows key I told you about. So just bloom, gone. So that's how you get your Windows key up, that's how you get your Windows key down. These guys here are just 3D objects we've got floating around. Say again? Oh, it's falling behind, is it?
No, you stopped it, it's refreshing.
Oh, the Windows key stops the capture, it does. Yeah, you're right. You're right. Stop live preview, live preview. There you go. So even, like, this is really cool stuff. That's the action1.ie website. So right over here, there's nothing on the wall there, but there's what looks like a 90-inch TV from where I'm standing. And that's a browser. So this is going to, you know, if you want to talk about disruption, TV makers are going to be disrupted. Monitor makers are going to be disrupted. The whole industry could be disrupted. This thing gets smaller, lighter, more, you know. Like this could be just like Google Glass was, that dimensions in 5 years' time. It's like, I think Bill Gates said, everyone overestimates what's going to happen in 5 years, underestimates what's going to happen in 10 years. That's a thing. So that is really everything I have for you guys. I think you have a feeling for what it is. I hope it was somewhat interesting. And I want to give as many of you a go on it as I possibly can. So thank you for your time. All right. So I'm just finished with the 3D camp presentation on HoloLens, where we went through what ActionPoint has done with HoloLens over the last couple of months. And I have to say the response from everybody present has been just phenomenal. There's been a lot of jaws on the floor. A lot of people kind of had heard of HoloLens but not really understood what it exactly is. And I think we were fairly successful in explaining and showing practically and giving hands-on experience of the benefit and value of what the new world of augmented reality can bring to modern business. So there's a lot of people that have a lot of thoughts as they leave here, and looking forward to hopefully doing the presentation again sometime.